Yes, welcome to our online class. Today we are going to derive the formula to which we can be able to find a distribution factor. Now that is KD. We are going to consider M number of coils connected in series in a coil placed in an adjacent slot. Now, let's assume we have something of this nature. I have this, I have this, I have this, I have this. Okay, let me have this of this nature such that this is my A, this is my B, this is my C, my D, and my E. Now I would like to join my A to E vectorially like this. Then let me extend this so that I have a kind of pyramidal structure. So then this to this and this to this. Now here we have angle what? Alpha. In fact, we have alpha here, alpha here, alpha here, and angle alpha here. The first thing we are going to do is we are going to find the arithmetic sum of the EMFs here. Now for us to find the arithmetic sum, I'm going to look for a point or draw a line that is going to be perpendicular to AB. That is, I'm going to have something of this nature from here. Then automatically, let me call this place F. Then automatically, you know that this part is alpha over 2. Very good. Now, if this is alpha over 2, and I want to consider AF, this is my R, radius R. This is my radius R, you know, the radius of this. I'm going to, if I want to find the relationship between AF, R, and the angle, you know, if this is the hypotenuse side, sine alpha over 2 is going to be what? That's opposite, that is F, or AF, because this is my point A, this is F. AF over what? Over R, which is the hypotenuse side. So my AF equals to what? R sine alpha over 2. The same thing occurs here between F and B. So AF is also equal to what? FB. So it means that AB equals to what? 2R sine alpha over 2. Now, if you are considering the number of coils, that is M number of coils in this series, you are going to have your arithmetic sum EA of EMF to be what? 2M, that is 2 times M number of coils, 2MR sine alpha over 2. Very good. So let us keep this very well. So I have over 2 here. Let us keep this very well. Now we are not going to consider the vectorial what? EMF, vectorial voltage. That is EV. How am I going to do that? Let me consider this side. Now let me call this, you know, this is forming a kind of 90 degree with this. Very good. Let me call this point G, and let me call this is my point E. So we are in a straight line. Very good. I'm going to consider this triangle. Let me call this point O. Point OGE, they form a right angle triangle. Now you know that I have M number of coils in this because it's a series. So my angle here is going to be what? M alpha over 2. M alpha over 2. So if I'm considering GE, OG, and R, what am I going to have? Let's consider the angle M, that is M number of angles of alpha over 2, now with GE and R. Now EV, which is our vectorial EMF vectorially, is given as looking at this, sine of m alpha over 2. If m is 2, it's 2 times alpha over 2. If m is 3, 3 times alpha over 2, depending on the number of m coils, number of coils you have, is equal to, this is opposite, right? GE over hypotenuse. This is R over R. Now, GE equals to what? R sine m alpha over 2. Recall that we are considering from A to E. Now, GE is also equal to what? AG. So if I got this to be, if GE is R sine m alpha over 2, and it's also equal to what? My AG. Very good. Equal to AG. So it means I'm going to have AE, which is from here to here. AE is going to be what? Vectorially, AE is going to be 2 multiplied by R sine m alpha over 2. Very good. Now, how do we now find our distribution factor? Our distribution factor KD is the vectorial sum of the EMF over what? The arithmetic. So I'm going to have EV over EA. Now, what is my EV? This is for EV. Why this other is for E? So find EV. My EV is this. Good. 2R sine m alpha over 2 divided by, what is EA? Our EA is 2mR sine alpha over 2. 2mR sine alpha over 2. From here, 2 can cancel out 2. R divides R. Then I have KD, which is the distribution factor, to be equal to sine m alpha over 2 over what? M sine alpha over 2. And that is the distribution factor. So you can try to make this very small. When you're writing, it should be KD, very small. Do you get now? KD equals sine m alpha over 2 over m sine alpha over 2. Where your m, this is the distribution factor. Your m is your number of slots per pole, number of slots per pole per phase. Generally written as m equals to slots over what? Pole times phase. That's how you calculate your m. So that's very good. So this is our distribution factor. Remember, the deal is that you must be happy, I must be happy, we must be happy. So do so well to comment, like, subscribe, and share. Thank you.